Happy morning to all the energetic participants. It is with great honor and genuine joy that SNS College of Technology, Department of Mathematics, welcome you all at the 5-day International Faculty Development Program on recent trends in applied mathematics. We are successfully on the third day. We are happy with the tremendous feedback and my hearty thanks to my management for this constant support and motivation. I also warmly welcome our supportive Dean, Dr. A. Vishwanathan sir, my colleagues and friends who are the backbone for this program. With all due respect, I welcome our resource person for today, Dr. T. Paliswamy sir, Vice Chairperson and Associate Professor of Mathematics, Amartya Vishwa Vidyapeetham, Coimbatore, for accepting the invitation to share the knowledge and experience with the fellow faculties. Last but not least, I am delighted to welcome all the distinguished participants for our 5-day International Faculty Development Program. Thank you for attending our program from all the regions of the world. I hope that you all would be definitely benefited through interaction with eminent personalities from academics. Welcome again. I hand over the session to Rakshan Shivakumar.
Hello. Madam, shall I start?
Yes, sir.
Can I start?
Okay, sir.
Okay, thank you. Right. Is it audible to everyone? Can one of the participants please respond to me? Is it okay that you are able to hear me?
Yes, sir.
Yes, sir.
Yes.
Thank you, sir. And tell me whether this is visible to you, this slide?
No, sir.
Morning, sir. Yes,
No?
sir.
It's not
It
visible.
is split
No,
up
sir.
into the participant and your presentation.
Excuse me, madam. Is it visible now or?
No, it is visible, but what I'm seeing is a partition between participants and your slide. It's not
Okay,
the entire.
therefore I had to choose the entire screen, right, madam? Let me see.
Yes, sir. It's visible now.
Okay now?
Okay, sir.
Yes, thank you. Yeah, thank you. Good morning, all of you. You have been listening to lectures of eminent persons from elite institutions of the country and from outside India. I'm so happy to meet you all through this webinar. And I personally thank Dr. Bhuvaneswari for giving me this opportunity to interact with you about my experience over this particular title, Principal Component Analysis. Anyway, we'll go straight into the content. I believe the time that is given to me is 1 hour exactly, but I may go little 10 minutes or 15 minutes more. You have to please bear with me. I think the organizers may be permitting me to do this if it is required. I'll try to see that I'm containing within the time. Suppose if it goes little beyond, you please bear with me. I take your permission, the organizers. So now I start my presentation. So this is about simply we'll be calling it as PCA. That is more familiar to almost many of you. You should have heard about it. It is much used in machine learning kind of thing and classification work and artificial intelligence kind of thing. Therefore, now let me start with what actually the content is. As this is a webinar, as we are not meeting personally, I made my content little simpler so that you can easily catch it. There should be no trouble for you to listen to me and get the idea what I'm going to talk about. Right. So I can tell you one simple example which can be connected to this PCA, and I'm going to present the example and how it is connected mathematically to this particular example. See, I believe that many of you might be interested in cricket. You all would be watching cricket matches often. When there is an event where the batsman is running for a quick run, and there is a doubt for the umpire whether he reaches the stumps before the ball hits the stumps, reaches the grease before the ball hits the stumps or not, is not clear to the umpire. Then we all know what's happening there will be, they will be presenting you different views of that particular event happened. They'll be showing you from rear, from different angles, say some 6-7 angles they will show you. So the reason is, if one is not clear for you to decide, then the other one will help you to understand what is happening there, whether he reaches first or the ball hits the stumps first. So here what I'm going to take now is, therefore, what had happened there is the same thing. It is only one event happened, but we are perceiving it from very different angles, which will give you different informations. When you collect all together, you will come to the understanding what exactly had happened. The same thing is what we are going to do here. That is what is connected to this principal component analysis. So how it is connected to mathematics, I'm going to present it now. Therefore, I repeat, an event had happened, that is a quick run by a batsman, and there was a doubt by the umpire and by the viewers whether he reaches first or the ball hits the stumps first. Then the view with which you are seeing will be stopped, and you'll be presented with very many different views. Out of all different views, which view is giving you the better understanding of what had happened, that will be taken for this particular problem of understanding whether he reaches first or ball hits the stump first. But remember, at the same time, if my aim is something else, then some other view may be better. For this particular problem of checking whether who reaches first, either he or the ball, one particular camera view may be better. If I want to see something else, then not this camera, the other camera may be better. That is why they are capturing the whole event by various cameras, and which will be useful for a particular purpose. That camera will be used for that particular purpose. So I can give you one more example. I believe that there are very many participants from outside Tamil Nadu also, but the example that I'm going to you now will be easy for people from Tamil Nadu to catch it. Hope you all, or some of you at least, are you all may be knowing that there was a film Virumandi in Tamil. So the story is told by two characters of the particular film. So first half will be narrated by somebody and the second half will be narrated by somebody, but the event is the same. But the viewers will be able to catch that there are, it looks like two different things, or there will be a lot of things that are not understandable with one person's view can be captured by the other person's view. Therefore, this is similar to the one that I told you earlier, like one camera may not tell you completely, but the other camera will explain you better. I stop here for a while. Please, any one of you respond to me. You are able to get my voice. There is no problem. Audibility and the point that I told you is okay for you. I'll proceed. Please give me your feedback. Audibility. Excuse me?
Yes, sir, it's audible.
Right.
It's perfect.
Okay,
sir.
thank you. I'll proceed further. Yeah. Now, how this is connected to mathematics is what I'm going to present for the next 5-10 minutes. You please listen. Now, I'm taking this particular slide. Watch it carefully. So, I'm multiplying this 1, 1. 1, 1, you can call it as a column vector, or I can call it as a column matrix, or I can call it as a vector. Vector 1, 1, I hope you may be knowing that I'm handicapped a bit because I'm not able to draw, but you can see that what actually it is. I'm taking x-axis, y-axis, I'm just marking the point 1, 1, and I'm connecting it to origin. Therefore, the line starting from origin ending at 1, 1 with an arrow is what I mean by this column 1, 1. So column 1, 1 is simply a vector that starts at 0, 0, ends at 1, 1. When I say vector, it automatically should start at 0, 0, and it ends at 1, 1. So now I multiply this one with 5, 3, 3, 5. I'm getting 8, 8. That's quite simple to understand. But I am doing something else in the next 3 lines. So please watch it carefully. So I am taking the same 1, 1 here also. The second line, that is not changing, same. But the multiplication is not done this time by 5, 3, 3, 5. It is by 0 0.5, 0 0.5, 0 0.5 minus 0 0.5. And out the next level, it is multiplied by another matrix that will be giving me 8, 0. And that output is taken to next level. It is multiplied by another matrix, and that is giving me 8, 8. So remember, 8, 8 is where I ended while I multiplied that 1, with 5, 3, 3, 5. But now the same job is done by 3 matrices. All 3 matrices together gives me 8, 8 out of 1, 1. Hope you'll be getting what I'm trying to tell you. When you multiply 1, 1, but with 5, 3, 3, 5, you'll be getting 8, 8. But now the 1, 1 is the starting vector, and 8, 8 is the ending vector, but the process is different. It is not the same as 5, 3, 3. Then my question is, what are they? Is it accident, or is it really possible every time? If I take some other true, we multiply these 3 matrices again, I get the same result like I'm getting for the multiplication of the vector by 5, 3, 5. The answer is yes. So now the question is how? What is the reason behind that, and how it is happening? So it's quite simple. Almost every one of you are knowing that. Remember, our purpose is something else, but these are all the things that are essential to talk about it. Therefore, I am talking about it. So now I tell you 0.5, 0.5, 0.5 minus 0.5 will take 1, 1, 1, 0. So what I am trying to tell you now is 1, 1. I told you already, you take x-axis, y-axis, you mark the point 1, 1 in the xy plane and connect it to 0, 0. The arrow at 1, 1 and starting point is 0, 0. That will be a vector. Now suppose I don't want to use my x-axis, y-axis as it is. I want to change my axis. Hope you'll be catching it. I give you enough time, see that you are getting it. I'm changing my axis system. How do I change my axis system now? I'm taking 1, 1 as my one axis. And axis is 1 minus 1. So maybe it will be helpful for you to listen, so to see and understand. I just show the next slide. See here. This 1, 0. Right, because any point on x-axis will be of the kind a comma 0, and I am taking particularly a vector of length 1, therefore I am taking 1 comma 0 along x-axis. And if you do the same thing along y-axis, any point on the y-axis is of the kind 0 comma y, therefore I am taking particular vector of length 1, therefore it will be 0 comma 1. 1 comma 0 is one vector, 0 comma 1 is another vector. With respect to those two vectors, I can get my 1 comma 1. Come on, you can understand it can be expressed as 1 into 1 comma 0 plus 1 into 0 comma 1, which will be equal to 1 comma 1. Therefore, that 1 and 1, which are the numbers multiplied with 1, 0 and 0, 1 or what is collected as that 1 comma 1, that is a vector representation. That's what is your vector you have taken as the input for the matrix multiplication. Hope you catch me. Hope you are comfortable with me. Otherwise, I repeat again. Please watch it.
Excuse
That
me, sir.
1 comma 1
Your audio is breaking.
Breaking, madam.
Yeah.
Let me see. Anyway, otherwise I'll go slow. Tell me if you have a problem repeated. I'll see to it what I can do. Is it now?
Yes, sir.
Right. Okay. Let me go slow. With respect to x-axis, y-axis, the input 1 comma will be the point that's a vector connecting origin 0, 0, 1, 1. What I mean by the column matrix 1 comma 1, otherwise it is vector. So that x-axis I am taking to be this bottom line. Hope you can see that I am showing on the slide by using arm. This particular part of the x-axis, otherwise I can write it as 1 comma 0. And this will be my y-axis. Any vector on the y-axis is of the kind 0 comma b, I will be taking particularly 0, 1. So by using 1, 0 and 0, 1, I can write my 1 comma 1 as 1 into 1, 0 plus 1 into 0, 1. That's what is your coordinate 1 comma 1. That is the input vector that I am using for the matrix multiplication. Now what I do, instead of this x-axis bottom line and this vertical line that is virtual, which is not there, I am taking now this blue line. Hope you all will agree that this blue line is passing through 1 comma 1, right? Origin and 1 comma 1. See, this is 3. This is also 3. Therefore, this point is 3 comma 3. So 1 comma 1 will be somewhere here. Therefore, I take this as my new x-axis. The old x-axis is thrown away. I have chosen new x-axis, which will be passing through 1 comma 1. And new y-axis will be this green line. That will be 1 minus 1 comma 1. I have written here 1 comma minus 1. It is not right. It must be minus 1 comma 1. 1 comma minus 1, that will be the extension of the same green line in the bottom fourth quadrant. So let's not bother about that. They both will give you the same thing. So now, if I use this axis system, 1, 1 and 1 minus 1, then I go back, your point 1 comma 1 will become 1 comma 0. So what had happened here in the first line is, the point 1 comma 1 is taken to 1 comma 0, meaning I have changed the axis system. I changed the axis system from XY axis to that blue line and green line. The new axis system, which is the vector 1 comma axis system. Hope you get it has become 1 comma 0. I will try to explain. I don't know whether it will be convenient in webinar. Please see that. This will be my point 1 comma 1 with respect to x-axis, y-axis. Correct, sir? This is x-axis. This is y-axis. With respect to that, this point will be 1 comma 1. Now, suppose you understand now this bottom line I threw away and the vertical line I threw away. Then I will have a particular line alone. Then this is my x-axis. Then remember my point 1 comma 1 is on the x-axis, on the new x-axis. And remember any point on the x-axis 1 comma 1 has 1 with respect to the new axis system. The algebra procedure I don't want to explain. Those who are knowing it, please understand it. If there are any engineering faculty that what I am presenting is orally or not perfect medical procedure, I'm explaining because my purpose is something else. Therefore, let me go with this. Therefore, now the point 1,1 that is here with respect to old x-axis, y-axis, now is with respect to this axis will be a point that will be having only x component, y component becomes 0. That will be the character for any point on the x-axis. Therefore, your 1,1 is with respect to old axis. Now the same thing has become 1,0 with respect to the new axis because it is on the new x-axis. I continue. So this first line is nothing but taking my point in normal xy axis to new xy axis. The next one is the work of this matrix. The work of this matrix 5335 is done by 800 diagonal matrix. So this matrix took 1,1 to 8,8. The same work now I do it in the new axis system. When I do it in the new axis system, the work of the matrix 5335 will be done by the matrix 8002, and the point 11 we already knew that it becomes 10. Therefore, the work of 5335 on 11 is the same as work of 8002 on 10. That gives me 80. This is the second line. Therefore, first line is doing the work of this matrix 5335, and hope you can understand what should be the third line. My work is completely happening in the usual XY system which I presented in the first line, but when I come to the last 3 lines, the work is happening in the new axis system, that blue line and green line. Therefore, axis changed, matrix performed. Now again I have to change the axis so that I can come back to the old axis system, XY axis. That is what is this work. So when I do that, I'll be getting my answer 8,8. Sir, hope you all can follow. If any trouble, just I give you 10 seconds break. Raise your doubt, otherwise I will continue.
Got it, sir.
Thank you. So this is axis change. This is work of the matrix. This is again pulling back to the old axis. So all these together, can I put this way? You please listen to me. I put this matrix first. And prior to this matrix, I use this matrix 8002. And prior to this matrix, I put this matrix 1, 1, 1 minus 1. So it will be looking like 1, 1, 1 minus 1 multiplied over 8002 multiplied over 0.5, 0.5, 0.5 minus 0.5. Hope you will understand when I perform these 3 matrix multiplication over 1,1, it should result in 8,8. Maybe it is available in the next few slides. Just I will try to show it to you. Yeah. No, it's not there. Let it be. So 3 matrix multiplications together gives me the same thing. This is what we normally call it as diagonalization.
Diagonalization.
Or canonical form or principal axis form we call. So in principal axis form, what do you do? Tell me. I'm getting a new axis. Over the new axis, I'm doing work of this matrix, and I'm pulling back again to the old axis so that I can get the same result to be verified. So do you think that it is something similar to the looking at that batsman reach the crease by different camera? This 1,1 is with respect to one camera. When I look at the same 1,1 using a different camera, it becomes 1,0 is what I'm coming to say. So it is same thing as what I already explained to you in cricket scenario. When you consider it to the camera, you understand it to be 535. X-axis, y-axis. When I change my camera to that blue line and green line, that 1,1 has become 10. Therefore, now I'm able to see better whether batsman reaches or not by using the new camera is kind of the feeling that you should have when I'm doing this. But the event is the same, right? Now we'll go over what actually the idea behind that. if mathematics people are there, it will be very simple thing. But remember, our purpose is something else. Just I wanted to give this for the sake of engineers. If you have any problem in understanding it, come on, we'll go to this now. So I told you what had happened. What is this 1, 0? What is this 1, 0? 1, 0 is nothing but the same 1, 1, but with respect to the new axis system that was given by blue line and green line. Therefore, my question is, what is this 1, 0? Answer is 1, 0 and 1, 1. They both are one and same, one and the same. Then how they are connected? They are connected in the sense that 1, 1 with respect to XY axis system will become 1, 0 with respect to the new axis system. Okay, I repeated enough. I'll go to the next one. So that's what I've explained with the picture. So see here now, 1, 1 with respect to usual XY axis system will become 1, 0 in the above axis system. Above axis system means this blue line and green line. So 1, 1 is taken to 1, 0 by the matrix this, which is the inverse of. Then you will be asking next question. What are these matrices? This and this. This 0.5, 0.5, 0.5, minus 0.5 and 1, 1, 1 minus 1. What are they? I'll tell you. This 1, 1, 1 minus 1 will be nothing but the new axis system. Tell me, this will be 1, 1. This will be 1 minus 1. Of course, instead of this line, you just imagine that line is coming down. That's what we are using here in the third matrix. This matrix is consisting of columns, which will be nothing but your blue line and the green line. Blue line is in the first column, green line in the second column. Let me go. Sir, I may be boring because I'm not seeing you in person. Therefore, I'm not able to grasp if some of you are having some problem understanding. Therefore, I'm going a bit slow. Please see that you are bearing with me if you are feeling that I am repeatedly telling that it is boring. Anyway, I'll see. I am picking up. So now going further, then you will ask the next question. What will be this? This is nothing but inverse of this. So now you understand the last matrix is nothing but the vectors that are taken as the new axis system. Blue line is 1, 1, green line is 1 minus 1. And inverse of this matrix is this. Hope you will understand why inverse. Because this is taking from one axis system, another axis system. And this is doing reverse. Therefore, one should be the inverse of the other. So if one is taking from XY axis system to new axis system, the other one should take you from new axis system to the old axis system. Then what will be this? This will be the matrix that is doing the same work of 5, 3, 3, 5, but not with respect to the XY axis system, but with respect to the new axis system 1, 1 and 1 minus 1. But now, what is mathematics behind that? It is quite simple. This 8 and 2 are nothing but the eigen values of this matrix 5, 3, 3, 5. You can quickly work. And what will be this 0.5, 0.5, 0.5 minus 0.5 or 1, 1 and 1 minus 1? That will be nothing but the eigenvectors. Therefore, the new axis system I framed are obtained just by using the eigenvalues and eigenvectors. Remember, when I make my eigenvectors as the new axis system, then a matrix with eigenvalues along the diagonal position will do the work of the actual matrix. I repeat, if I change my axis system to the eigenvectors in the columns, then the work of the given matrix will be done by a diagonal matrix which will be consisting of the eigenvalues in the diagonal position. Is that okay? Understandable or catchable? So if I take my matrix to be, if I take my axis to be eigenvectors, then the work of the matrix 5, 3, 3, 5 will be done by the matrix which will be consisting of eigenvalues along the diagonal position. The other matrix is the inverse of that. Simply speaking, it is diagonalization. I have done diagonalization means I have changed my problem from one field to another field. I have worked out it. Or simply speaking, if I have a work that has to be done at Coimbatore and I feel that this work is difficult at Coimbatore, I am taking that work to Tirupur, I am getting it done, I am pulling it back. So taking it to Tirupur is by the first matrix 0.5, 0.5, 0.5 minus 0.5. Do the work at Tirupur, that work is this. After completing the work, then I am taking back to Coimbatore, that will be done by this matrix. Taking to one place because the work at my place is not convenient, doing the work at the other place and getting back to my old location. So the work is now done at Coimbatore. Work is completed. Now the output is available at my place. Right. Let me come back to the problem now. Therefore, my point is now this. So out of all those process of diagonalization, etc., let's not bother too much about that. The one point that I wanted to tell you is, are you able to see now 1, 1 will become 1, 0? The point that I'm understanding is 1, 1, that when I change the axis system will become something else. That is what is shown here in the picture. If one point is becoming something else when my axis system, when I take a group of points, for the group of points also the same thing may happen. See here, now I'm just plotting all these green dots. Green dots are many different points, like we have taken only 1 point 1, 1 in the previous example. That 1, 1 has become 1, 0. Similarly, if I take all these points now, I am visualizing that with respect to this thick line, x-axis and y-axis, or usual line x-axis, y-axis, then the same points I can view through this particular dotted axis system, which is written as PC1 and PC2. PC1 is one new axis, PC2 is another new axis. So now I am seeing the same point with respect to the new axis system instead of the old dot line. So or old white line. Old white line I removed because that was the old axis system. Now I am seeing the same points through the new axis system, which are marked as PC1 and PC2. It is similar to the one that we discussed so far, that 1, 1 has become something else. 1, 1 has become 1, 0 with respect to the new axis system. So like a single point, a group of points also can be viewed through a different axis system is what I wanted to tell you using this slide. Right, let it be. Now I'll come to the job, principal component analysis. I wanted to tell you something about a point can be represented as some other, or a point with coordinates 1, 1 can be represented as 1, 0. This difference is because of different axis system. 1, 1 with respect to one axis system will become 1, 0 with respect to another axis system. Similarly, if I have group of points with respect to one axis system, they can be looked to other axis system, then their coordinates will change. Their view will change. The points will be looking differently when I look through different axis system. Okay, right. Now let me go with the problem, sir. Come on. So now all these things are again, we have already talked about. I'll skip those slides. So this is what I wanted to tell you. 3 matrices multiplied together is giving this 8002. Therefore, the work of this matrix 8002 will be done by all these 3 matrices. Or if I take reversely, I can put this 1, 1, -1 inverse. So otherwise 1, 1, 1, -1 here, 0.5, 0.5, and 0.5, 0.5, 0.5 minus 0.5 here. So if I change the order, I can put it here, then 5335 will be represented by 8002. That I already talked about it. Let me leave it now. Let me come to the work now. So what is PCA? Before going to PCA, we are starting our content now. So the finished one is 1.1, 1 need not be 1, 1 always. When axis changes, the point coordinates also will change. Or otherwise, it is something like Rama in one story may become Krishna in the other story. Or a hero in one film may be taking a role of Rahul, may become something else. He may become, say Robert in the other film. Therefore, 1, 1 is like Rahul, 1, 0 will be like your Robert. But still the point is the same. Physical locality is the same. Now I come to my point. I am giving you a job. You please think over. There is a work in front of you. You are representing a software company. You have come to a college to recruit students for your company. There are 5,000 students in the college. And you want to recruit only 1,000 students out of them. And you have to select. How do you proceed? You just imagine. Just I am telling you, this is my procedure I am telling. Hope you will agree with me. I am taking a scores of first semester, second semester, third semester, fourth semester, fifth, sixth, seventh, 8th still has to appear. Therefore, I don't have 8th semester result. Therefore, 7 SGPAs are there with me, or 7 percentages are there with me. So 7 values are there with me. 7 real numbers are there with me. And I will take his +2 score, that is 8th. I'll be taking his 10th score, that is 9th. And I'm taking some other performance of him, like took part in a competition, or participated in a workshop, or presented something conference. I'm taking all these things. For them, I'm just giving a number. So that also will become a real number. That is my 10th real number added to that particular 9 already I have. Therefore, 9 plus 1, 10 quantities I am having for that particular student, for every student. Therefore, for me, a student by name Ram may be the 10 component vector for the machine that I'm going to use to this selection procedure. A student Ram for me will be having 10 informations, 7 about his semester score, 2 about his +2 and 10th score, and 1 about his other performances. Taking all together, there will be 10 informations about him. All those 10 informations I pack as a vector. Therefore, I have a 10 component vector for the particular boy Ram. So now there are 5,000 students in the college that will be appearing for the interview. Therefore, I will have 5,000 such 10 component vectors. Like I told you already, there are x-axis, y-axis, in which 1 will become with 1 0 with respect to new axis. Now I am coming to the point here. I have 5,000 10 component vectors which can be plotted in 10-dimensional space. I need 10 axes which cannot be imagined, which machine can do. Let us assume that there are 10 axes. In that 10 axis system, 10-dimensional space, one particular student Ram will be a point plotted there. Now I take all such 5,000 students, therefore I will have 5,000 points plotted in the 10-dimensional space. Clear? So now what I want to see is whether there will be an axis system which, when I use, will automatically classify the students who can be selected and students who can be asked to wait and students who can be rejected. You get my point, sir? Remember, my work is to select 1,000 students out of 5,000 students in a college. But a student for me, when I want to use the machine to do this process, will become a 10 component vector for the machine, because I have 10 informations about the student. Similarly, 5,000 students, therefore there will be 5,000 such points. All those 5,000 such points will be in 10-dimensional space. Let me assume now all 5,000 students physically I am witnessing will be witnessed by the machine as 5,000 vectors in the 10-dimensional space. So there are 10 axes. Using all those 10 axes, every point will be plotted. Therefore, 5,000 points are now the plot. Now what's happening? I raised the question already. Please listen to it carefully. I am checking when I plot the points, when I look at it, I have no idea how I'm going to do that. It means I'm talking about the machine. Machine is feeling. I don't understand how I can do the work of selecting 1,000 students out of this 5,000 students. For that, of course, I have to give the comment. So how I'm going to proceed is what I'm telling. What I'm going to do is I'm going to change the axis system, because with respect to this axis system, that machine is not able to identify the difference between the students. It's not able to see the discrimination. It's not able to discriminate the 5,000 students. But I already decided that I'm going to choose some of them immediately. I'm going to put some people on hold for some more time for further examination, and some of them will be immediately rejected. Therefore, what I'm thinking is the current axis system is not helping me to discriminate the students, but by using my linear algebra knowledge, I doubt there may be some new axis system with which, when I see, these points will be automatically classified. These students can be selected. These students can be asked to wait, and these students can be rejected. That will be very much possible if I change the access system, is my belief, because of my linear algebra. If that is the thinking that I'm having, then tell me what will be the next question. What should be that access system? How can I get that access system? Is what I'm starting to think. For that, I need a little bit of statistics. Sir, is that work clear now? I don't need to repeat, I believe. Please, one of you respond.
Yes,
is
sir.
it okay?
It's clear.
Right. I proceed further. Now, what I do regarding PCA, some informations are given here. Those informations I leave it to you to read, but I'll come to the point. This is what is the basic with which I'm talking. When I'm talking with an example. The theoretical part of that is given in the slide. You please see to that. Now, one more information also I have to add. See to this picture. There is a ball that is in the real world. There is a spring attached along x-axis. Hope it is understandable when you look at the picture. Along x-axis, there is a spring attached. At the edge of the spring, there is a ball. When the spring moves, automatically ball moves. Remember, I am not so clear about how the movement is going to be. Therefore, as this is happening in 3-dimensional space, I think there may be 3 cameras required. One to catch the movement along x-axis, one to capture the movement along y-axis, one to capture the movement along z-axis. That's what camera A, camera B, camera C. Now, when I know the problem, I know pretty well that this is happening completely in x-axis only. Therefore, there is going to be no information from y-axis and z-axis. Therefore, camera 2 of the cameras may be not required for me. Just one camera will capture the complete thing. Therefore, there may be some unwanted cameras also. So we will come to the point now. So when you are going for the selection, I have taken 10 informations of the students, and it becomes a 10 component vector. It is plotted in 10-dimensional space. Now I have to classify for that. I am thinking this axis system is not good. Therefore, I am going for a new axis system, which will help me to classify easily. When I go for that, I have a small thinking whether all the 10 axes are important for me, or all the 10 informations are important for me, or some informations are redundant. Just for example, I am telling there may be some relationship between his +2 score and semester 1, semester 2 score, semester 1 and semester 2 score. I hope you all will be agreeing, because I am telling you just a reasonable case, because the student immediately after completing his +2, when he comes to first year, he will be with the same spirit of proceeding further to get better and better performance. Therefore, his first semester and second semester performance will be almost close to the performance that he has in +1. And of course, subjects are also science subjects. When he moves on to third semester, he becomes second year student. He will have all such kind of small different behavior. He doesn't want to be very serious like he was in +2. Therefore, his performance may slightly change. Therefore, what I am telling now, the +2 score and first semester, second semester score, they all will give the same information. Then all these 3 axes can be represented by just one axis. 2 informations, 2 further informations are not required, because instead of 10, suppose if I'm able to have 7, it will be convenient for me naturally. Machine can work conveniently. Therefore, that is also possible. That is what I try to explain by using this picture. If the movement is completely along x-axis, then the movement along y-axis and z-axis need not be captured. Therefore, 2 cameras are redundant. That's not relevant to me. I can leave them. The work that I wanted to capture through 3 cameras, I can just do with 1 camera also. The same thing is what I want to say. I want to relate it to the example that we are discussing. If there are the same as the decision that I'm deriving from 3 informations like +2 and semester 1, semester 2 score, then I can drop all the 3. Instead of all the 3, I can take 1 information, either +2 or average of all the 3 or whatever. Then instead of 10 information for a student, it is enough for me to decide with just 7 informations. Therefore, 5,000 into 7, it becomes only some 3.5 something 5,000 into 7. Therefore, it is 35,000. Whereas if I take all 10, it will be 50,000. Therefore, definitely a reasonable amount of data is reduced. So that is also very much. Therefore, the problem in my presence is now, what access system is better for me to classify these 5,000 students? Like, some of the students can be selected immediately, some of the students can be hold on, some of the students can be rejected, and whether I require all 10 informations per student or some 5 or 6 informations will be enough to take the decision, which will not be different from the decision if I consider all 10. So these are the two thinkings I'm having in mind. So if I want to execute that, how can I go? So all these informations are again about theoretical part of that. I will leave it to you. You please read it and you try to understand it. Now, coming to this, I repeat again, what is my access system? By using which access system I can take my 5,000 vectors in the 10-dimensional space conveniently so that I can classify easily. I proceed now. I do like this. Say, now I need a bit of statistics. Hope you may be knowing variance. And I'm going to use variance and covariance, both of them here. I'm just showing you the slide. I just tell you, what do you mean by variance? Before variance, immediately what we come to know is mean. Say, for example, I am telling you again an example of cricketers. 2 cricketers are there, say A and B. I consider just 2 matches out of them so that it is easy for grasping. One player has got 100 and 100 as his score in both the matches played. Other player is having 200 and 0. Now, let me assume that we are in the selection committee. I have to select one player out of these 2 players. So what shall I do? I'll just consider the average score. See here, both of them are having average 100. So now it's very difficult for me to decide who will be the better one. Therefore, just by using mean, I cannot decide. So what I do, I go for variance, next item. What is variance now? Or instead of saying variance, I will tell you this. See here, now which player is preferable for us is quite easy to say, just because I'm giving you only 2 data. You all can answer immediately. The one who is having 100 and 100 is better because he is always reliable. Whereas the other on 200 and 0, he is not reliable. Sometimes he may have very high score, or sometimes he may be very poor scorer. It may not be good for me. Therefore, I'll go for the player who is always consistent with 100 and 100. Of course, this is an example just with 2 scores. It may not be good in practice, but just I'm telling you so that you can understand what do you mean by variance. So the point that I'm considering here is, when averages are the same, I'm bothering about the consistency. Who is consistent? The one who is having much variation is the player who is consistent. So how do I measure it? That is what is measured by variance. How to measure it? Tell me. I tell you, please make a note of it. The first player is having 100 and 100. Average is also 100. The scores 100, 100, average 100. I am doing this. From score 100, I am subtracting the average 100. And from the second score 100, I am subtracting the average 100. Therefore, 100 minus 100, 0, 100 minus 100, 0. Therefore, 0 and 0 are here. For the next player, if I do the same thing, scores are 200, 0, average is 100. If I subtract 200 minus 100, 100, another 0 minus 100, minus 100. So now remember, when I take this difference, one player is having 0, 0, 0. Another player is having 100 minus 100. That also, when I add, it is 0. So, though the details inside are different, the total is the same. Then I have to overcome that. For that, what I do, this is just because of the plus 100 minus 100 that has become 0. Another is always 0. So now I take next step to overcome the problem of this sign. I'll just square it. 0 square, 0 square, that is again 0. Whereas that will be 100 square and minus 100 square, that will become 20,000. So now I see the square of the difference of the scores from the average I calculated. That gives me the information about the consistency. One who is having lesser value for this deviation is what? Consistent, whereas the other one who is having high difference is inconsistent. Or otherwise, this is what we are calling as variance. So variance will give you the measure of difference in the items or how the items are differed from the mean. Right. Next one is covariance. Covariance will be coming into picture only when you are dealing with two informations. So I talked about the score of a player and score of another player. Now I come to a 5-day match wherein one player will be having innings 1 score, innings 2 score in one match, and innings 1 score and innings 2 score in another match. Similarly, the other player. Therefore, for every player now I am assigning 2 values now. Therefore, when 2 values are coming, then I am just trying to read how they are varying. Then where I have to do, tell me. Earlier it was just one information which I can take along x-axis. Now there are 2 values, therefore I have to plot in the xy plane. I'll take the first player, 2 scores, say 198 and another one 197. So I'll be plotting this 198, 100,98, 100,97 in xy plane. Similarly, the other player, that will also I plot. Then I will see how they are varying. So say player 1 and player 2 together, how the variation is happening. Like the variation among the single score we studied. Now we are going to study variation between 2 scores. How they are varying. Say for example, I am plotting all the scores on xy plane. Then I am watching how they are, how the plot looks like, how it is looking like, or I can say otherwise, what is the relationship between all the points. So instead of saying how they are varying, I can say otherwise how they are related. Are they all so close? Are they all scattered? How they are related. So how they are related is what is given by the information covariance. So this variance and covariance we are going to use for our purpose. Remember, I go back again to the problem we have in our hand. 5,000 students, 10 informations for every student. Therefore, I have 10 component vector for every student in my machine. The machine will look at every student as a 10 component vector. I plot all of them. It will be in 10 dimension space. Therefore, in 10 dimension space, there are 5,000 students, 5,000 points plotted, and the machine wants to classify these 5,000 students like who can be selected immediately and who can be asked to hold and who can be rejected. For that purpose, I am using my linear algebra knowledge. So this axis system in which I plotted is not helping me better. Therefore, I am thinking that I can go for a new axis system, for which how I have to choose my axis system is the question in front of me. For that only I talked about variance and covariance. Now come on, I'm just giving you this particular idea about this 5,000 students and 10 components. Just listen to me 1 minute carefully so that you understand it. I'm taking first row will be 10 informations of the first student. So 1 row, 10 column, correct? 1 student, 10 informations that will be plotted in the first row. That will be taken in the first row. Therefore, 1 row, 10 column. I put second student, third student, etc., 5,000 students. I plot all 5,000 students scores in the matrix form. Not plotting, I mean, I have written. Therefore, now finally it becomes a 5,000 row 10 column matrix. This 5,000 row 10 column matrix, what I do, I am taking first column will be standing for what? You please think carefully. First row is the information about a particular student. So that means 10th score, plus 2 score, semester 1, semester 2, etc., semester 7, and the awards, etc., etc. So if I take first column, that will be the information of all the students of his 10th score. Then second column will be information of all the students about his plus 2 score. Similarly, the rest of the things. Now what I do, are they related or not? I am going to check by taking the covariance of these 2 matrices or these 2 columns. Column 1 and column 2 I'll study the covariance of that. So meaning what? How they are related I want to study. Similarly, first and third, first and fourth, first and fifth, etc., first and 10th. Then second and third, second, fourth, etc., second and 10th. Third, fourth, everything I am taking. Therefore, tell me what will happen, sir? I'll be finding relationship between first column and second column. That means 10th score and 12th score of all the students. Then 10th score and semester 1, 10th score and semester 2, 10th score, etc., semester 7, 10th score and award. So I denote it as sigma 11. That is what we are calling as variance. Sigma 11 means covariance of first column with first column. Covariance of first column with first column will become variance. Then second one, sigma 1, 2. That will be giving you covariance of first column with the second column. That means relationship between 10th mark and 12th mark. That will be sigma 1, 2. And similarly, if I write, I'll go till sigma 110. Hope you will understand it. That will be along the first row of my matrix. So first row of my matrix now becomes the
Not able to see the slide.
And second column, first column and third column, etc., etc. Of course, first column with first column also. So the entries will be sigma 11, sigma 12, etc., sigma 110, which will be the covariances of all these 10 columns. Then second row, what I do, second row with the first column, sigma 21, second row with the second column, sigma 22, etc., sigma 210. So similarly, if I do,
Sir, new slides are not visible. New slides are not visible.
Madam, which is not visible?
Slides are not visible. It is old only.
Madam, I have not changed. Still, I have not changed. So I don't have slides with sigma 11, etc. You have to grasp it. Madam, this is okay.
Okay, sir.
Yeah, right. Therefore, I am telling you now a matrix which will be consisting of the relationship between first column and second column, etc., etc. First column with 10th column, that will be the first row. Similarly, second row, relationship between second column and first column, second column and second column, etc., etc. It will be 10 entries. Similarly, I will go till where? Relationship between 10th column and first column, 10th column and second column, etc., etc., 10th column and 10th column. So I'll finish up with your matrix. Now tell me what should be the size of the matrix. One, first row, first column, etc., etc., first row, 10 column, 10th column. Therefore, you will have 10 entries in the first row. And similarly with second column and first column, second column and second column, etc., etc., second column and 10 column, you will have 10 entries. And finally, 10 row and first column, 10th column and first column, 10th column and second column, etc., etc., 10th column and 10th column, that will be the last row. So you will have now
10 by 10 matrix.
rows, 10 columns. So earlier we started with what actually? 5,000 rows and 10 columns. Now I got a new matrix which will be having 10 rows and 10 columns. What will be the 10 rows and 10 columns? All the entries in the matrices are what? It will be the relationship between first column and second column, first column and third column, etc., etc., first column and 10th column. Then second row, second column and first column, second column and second column, etc., etc., second column and 10th column. Last one is 10th column and first column, 10th column and second column, etc., etc., till 10th column and 10th column. Therefore, it will be a 10 by 10 matrix. Now I come to the point. Are you able to grasp what will be the first row second entry? First row second entry in the 10 by 10 matrix is what? The relationship between first column and second column, am I right?
Yes.
And suppose if you come to second row first column, what will be that? It will be the relationship between second column and first column. Tell me, the relationship between first column and second column is the same as the relationship between second column and first column. So first row second entry will be the same as second row first entry. So similarly, if you look at it, first row will become your first column. So once if you finish all the work, you will see that the matrix is a symmetric matrix. First row is the same as first column, second row is the same as second column, third row is the same as third column, etc., etc. 10th row will be the same as 10th column. And if you are taking the entries along the diagonal positions, it will be like the relationship between first column and first column, relationship between second column and second column, relationship between 10th column, 10th column, that will be nothing but variances. So the matrices you have got now will be nothing but covariance matrix, where all the entries are talking about relations of ith column and jth column, and whereas the diagonal entries are nothing but the relationship of ith column with ith column, which we call as variance. Therefore, this matrix will be having covariance in all the other positions and variances in the diagonal positions. This matrix we call by the name covariance matrix. We are coming to the close of the discussion. See that this point you are catching it. Now, I told you earlier, the points plotted are not comfortable to me to discriminate for my purpose. Therefore, I wanted to have a new axis system. For that only, I have brought the idea of covariance and variance. And now, how your covariance and variance can help you. I'm telling you, suppose if you are looking at the student in one particular axis system, all the 5,000 students, if you plot, you can see the relationship between the 12th score and first semester score, 12th score and second semester score may be same, may be relevant. But now I can find a new axis system, because when you plot in your axis system, I'm using a different axis system, then the points will change. Therefore, then when the point is changing, the relationship can be nullified. I can find an axis system in which the relationship can be removed, because the point 1, 1 has become 1, 0. Like points are changing, here the 10 component vector, their components will change. When components changes, if there are already some relationship, that relationship can be removed when I use a particular axis system. Hope physically this we cannot understand, but mathematically this is possible, because all 10 component vectors of 5,000 students, when I use a new axis system, will be different. Therefore, the points will be like the relationship between them can be removed. When there is relationship, this matrices I have taken, all the entries will be non-zero entries. Suppose if I am able to see an axis system where I can eliminate the relationship between the first column and second column, and first column and third column, etc., etc., what should happen? That relationship is measured, and that is what is entered in the entries of the matrices. When the relationship is removed by using a particular axis system, what should happen? The entries will become zero. Which entries will become zero? The relationship between first column and second column. Now that relationship is removed by choosing proper axis system, therefore that entry will become zero. Similarly, first and 8th, first and 9th, first and 10th, therefore all those relationships will be removed by choosing properly the axis system. Therefore, all the entries other than the diagonal entries will become zero, because non-diagonal entries are nothing but the relationship between one ith column and jth column. Now I have chosen an axis system in which the relationship between ith column and jth column is removed. Therefore, the relationship between ith column and jth column will become zero. Therefore, all the entries will become zero except for the diagonal entry. Come on. Therefore, what had happened now is, if I choose a proper axis system, I can make my matrix a diagonal matrix, where only in the diagonal positions I will have the variances, non-diagonal positions will become zero. So meaning what? I want such an axis system wherein this covariance matrix will become zero. Covariance matrix will become a diagonal matrix. So this is the axis system which we are looking for. Once if this happens, then what will happen? Tell me. By using this new axis system, when I look at the plot of all 5,000 students in the new axis system, the relationships are removed. Therefore, the point is very clear for me. Therefore, I can easily discriminate by using the new axis system, because relationships are removed. Therefore, the confusion is removed. Therefore, by using the new axis system, I can see 1,000 students which are quite good, and some 500 students which I cannot decide immediately, and rest of the students in some other different location. Therefore, by looking at the location, I can decide these 5,000 students I can select immediately. These 500 students I can ask them to hold, and other students can be asked to say that you are not required for us. We are not going to recruit for you. Therefore, this will be possible only when I make my covariance matrix a diagonal matrix. How can you make your covariance matrix a diagonal matrix? By choosing the proper axis system. How does it help? Because when I plot all the points by using the old axis system, and then when I calculate the covariance matrix, that will be something else, which will be having all the entries non-zero. But when I change the new axis system, like we have done in the first example, 1, 1 has become 1, 0. With the new axis system, what would have happened? Now all the points will be plotted in the new axis system, for which if I go over the covariance matrix, all the non-zero entries are zeros. Only diagonal and all the non-diagonal entries are zero. Only diagonal entries are present as non-zero. So work is done now. I have chosen the axis system with which the relationship between any two informations are nullified, and by doing that, I can see the plot conveniently, or machine can see the plot conveniently, with which it can easily classify, which can be taken to be group 1, which can be taken to be group 2, which can be taken to be group 3. Then one more point is there. We are coming to the close of the discussion. So now it classified like 3, and now I talked about whether all the 10 informations are required or not. There comes the other point. Now see, I am showing a picture. See here. This is a plot of 2 dimension. With this plot of 2 dimension, let us try to understand the 10 dimension now. So one is this axis, that is sigma square signal. It is lengthy. The other one is sigma square noise. It is short. Therefore, if I have 2 informations of a student, for example, this sigma square signal will be taking complete spread. This will give me better variation. Remember, this variation may be different when I choose different axis system. But remember, this axis system is chosen by taking my covariance matrix to be diagonal. After doing that, when I see the variances, that are the elements in the diagonal entries, for a 2 by 2 matrix, it will be only 2 diagonal entries. One is the sigma square signal, other one is sigma square noise. You can see now this gives you better discrimination. The discrimination goes from here to here. I can discriminate them much better. But here, all of them are so short, therefore discrimination will be difficult. Therefore, now if I have a 2 by 2 matrix, out of the diagonal entries, if one diagonal entry is large, that will be giving me more information than the other diagonal entry, which is lesser. That particular information will not be giving me much discrimination. Similar to this, now you come to the point of that 10 by 10 matrix. Out of all 10 diagonal entries, if just 3 or 4 diagonal entries are higher and rest of the 7 are so small that 7 entries which are corresponding to the smaller one will not help me to classify. Therefore, which will help me to classify is the one that is having much difference. Therefore, I'll be choosing only those 7 axes instead of all 10 axes, or only those 7 components instead of 10 components to classify my students, to classify the vector. Therefore, what works are completed now is I could see that I'm able to see it in a better axis system so that the plots are very clear for me to discriminate. And the second one is I could see that the 10 informations are not required to me. Sometimes some 6 or 7 may be enough for me. That can be decided just by looking at the diagonal entries which are higher and which are lesser. So look at the take a threshold. Using the threshold, you see which are higher and which are lesser. Those diagonal entries which are higher will help me to classify better. If there are few diagonal entries which are very smaller, that will not help me, I can leave them. Therefore, out of 10 information, some 3-4 informations may not be enough needed for, may not be required for me. I can complete the work just by taking 6 informations out of, instead of taking all 10 informations. Both will be possible by doing this work. So to accomplish this, what we wanted is the different representation of a point by using different axis system is required to be understood. That is linear algebra. And we require the variance covariance so that you can understand what finally we are doing is we are making our points in a new axis system. That axis system is chosen such that the new axis system should make my covariance matrix a diagonal matrix. So you have to choose the axis system for which the covariance matrix is diagonal. That helped me better to discriminate, and one step ahead, some of the informations that may not be required for me, I can eliminate just by looking at the diagonal entries in the covariance matrix. So the corresponding axis system can be removed. Out of 10 axes, 3 axes can be removed. The 10 component vector can be made to be 7 component vector. Definitely that will reduce the work of mine. I can easily complete. So by doing this, the classification work can be done better. Therefore, your principal component analysis helps you to classify. It is not classification, but it helps you to classify. By doing what? By choosing the proper axis system and by eliminating unwanted axes. This is what is the idea behind principal component analysis, for which lot of linear algebra knowledge and your statistics knowledge are required. Once when you are comfortable with the linear algebra understanding and the statistics, it can be done very easily, it can be accomplished. I complete my presentation. I have not used much of my slides. I spoke. Hope you would have taken it comfortably, I believe. So with this point, I just conclude my talk. If any questions, I am prepared to answer. Otherwise, the organizers can see how I have to proceed further. Please.
Sir,
Thank you. Madam.
sir, before we open the floor for queries, please can I go ahead and introduce you to the gathering, because due to some technical issues, I was not able to do it.
Madam, repeat, madam, please.
Sir, before we open the floor for queries, please can
Okay.
I go ahead and introduce you to the gathering, because in the
Okay.
beginning, due to technical issues, I was not able to do it.
Okay, madam.
We all know how mathematics is important in our life. Maths helps us have better problem solving skills and helps us think analytically and have better reasoning abilities. And one such person who teaches us analytical and reasoning skills to solve problems and look for solutions is our professor. Yes, our speaker for today, Dr. T. Palanisamy, is one such amazing person who joined the Department of Mathematics of Amrita University of Technology, Coimbatore in 2002 and is presently designated as Associate Professor, Vice Chairperson in Department of Mathematics, Amrita School of Engineering, Amrita Nagar, Coimbatore. He obtained his doctoral degree from Amrita Vishwa Vidyapeetham, Coimbatore. His area of research is the estimation of various functions in heteroscedastic regression models. His research interests also include regression analysis, signal processing, and image processing using wavelet techniques and sparse representation theory. He has published a number of research articles in reputed national and international journals. One of his research articles, written along with 2 BTech students, was identified by the editor of International Journal of Electrical Engineering and Informatics as the article of Editor's Choice of 2016. The authors were honored by an award of $2,000 USD along with a memento in the annual meeting of the journal held at the Technical University of Berlin, Germany. He has organized an international conference on applications of fractals and wavelets in January 2015. He has participated and presented in many international and national conferences, workshops, seminars, and training programs. He has delivered a number of lectures in faculty development programs, workshops, seminars. He is member of Board of Studies in few colleges. Sir, thank you so much for accepting our invitation in such short notice, and SNS College is very proud to have had you with us today.
Thank you, madam. Thank you.
Dear participants, the floor is open for queries. If you have any questions, please go ahead and post it in the chat box.